Good morning, students. Our today's topic is identification of the anions. In the topic of identification of the ions and gases, in the subject of chemistry, paper number 4, that is alternate to practical, and in short, this is called ATP chemistry paper. So this is a very important topic. So concentrate yourself. We are going to start. So here is the table. Actually, you have to learn these ideas and concepts. So this is the original thing. The rest of the things are just explanations. So these are very precise ideas and concepts of the identification of the anions. So look here, we are going to start now. Table below summarizes the tests used to identify the anion. So if the anion is carbonate, that is CO3 2 minus. So the test is method number 1. So there are two tests actually. So method number 1, add dilute hydrochloric acid. And if the bubbles are liberated and the liberated gas into the lime water. So if observation is this one, that is effervescence and white precipitate is formed and lime water turns chalky, so that will be the sign that the anion is carbonate. So look now, if we add dilute hydrochloric acid into our anion and bubbles are formed and a gas is liberated, so then that gas will be passed through the lime water. And if we observe the effervescence and white precipitate are formed and the lime water turns chalky, so then it will be the sign that the anion is the carbonate ion. Here is another method to identify the carbonate ion, that is heat carbonate strongly in our test tube and pass the liberated gas into the lime water. So I'm telling you that when the carbonate is strongly heated, carbon dioxide gas is formed. So definitely when the gas liberated will be passed through the lime water. So this is a test of the carbon dioxide gas as well. So white precipitate will be formed and lime water turns milky. So if the lime water turns milky, this will be the sign that the carbon dioxide gas is this one. And if the carbon dioxide gas is formed by heating the substance, so it will be the sign that this is the carbonate ion. The next anion that we are going to identify is the chloride ion. So there are again two methods. So the first method is add dilute nitric acid and add silver nitrate aqueous. So if we observe that white precipitate are formed that are insoluble in the acid, acids are nitric acid and silver nitrate. So if the white precipitate are formed which are insoluble in the nitric acid, so that will be the sign that this is the anion which is chloride ion. Here is another method. So if we add aqueous lead nitrate into our given sample and add dilute nitric acid, if white precipitate are formed, and if these are soluble in the acid which is nitric acid, so this will be again a sign that this is a chloride ion. Next, we are going to identify the iodide ion. So if we add, again there are two methods. So first method is if we add dilute nitric acid into our given anion and add aqueous silver nitrate, if the yellow precipitate is formed this time and if the yellow precipitate is insoluble in the acid was nitric acid, so this will be the sign that the anion is the iodide ion. So here is the second method for identification of the iodide ion. So if we add aqueous lead nitrate into our sample anion and add dilute nitric acid, and if yellow precipitate are formed which is insoluble in the acid, so that will be the sign that the sample anion is the iodide ion. Next, we are going to identify the sulfate ion. So if we add dilute hydrochloric acid into our sample anion and add aqueous barium chloride into our sample anion, and if a white precipitate is formed which is insoluble in the acid, that is hydrochloric acid, so that will be the sign that this anion is sulfate ion. Here is another method, that if we add dilute nitric acid into our sample anion and add aqueous barium nitrate into our sample anion, and white precipitate is formed which is insoluble in the nitric acid, so this will be the sign that this anion is the sulfate ion. Okay, if the nitrate anion is going to be identified this time, now there are two methods again. If we add aluminium powder into our sample anion and add excess aqueous sodium hydroxide and heat the mixture and test the gas evolved with litmus paper and concentrated ACl. So if the gas turns red litmus blue and gas forms dense white fumes with the ACl, so that will be the sign that this anion is nitrate ion. Here is another method to identify the nitrate ion, that is if we heat nitrate strongly in a test tube and observe the gases given out and place a glowing splinter near mouth of the test tube, if the reddish brown gas given out and colorless gas wrinkles the glowing splinter, so that will be the sign that this anion is nitrate ion. Okay, here is just the explanation now. So that was the original thing, that was the table. So here is just the explanation now. Carbonates react with dilute acid to liberate carbon dioxide. This is the general equation, that carbonate plus acid forms salt, water and carbon dioxide. So this is the thing that will decide that this is the anion which is carbonate. So carbonate plus 2H plus form CO2 plus H2O. Calcium carbonate, here is a particular example now. Calcium carbonate is going to be reacted with ACl and CaCl2 plus CO2 plus H2O is formed. So this gas will identify the carbonate ion. So look now how. So dilute hydrochloric acid and is reacting with calcium carbonate. Gas will be formed and that will be passed through the lime water. If it turns the lime water chalky, so that will be the sign that calcium carbonate is the gas and the carbonate ion is there. Carbonates decomposes when heated. Carbon dioxide gas is liberated. Metal carbonate plus heat, metal oxide plus carbon dioxide. So again, carbon dioxide will identify that carbonate ion is there. So here is an example, that copper carbonate is heated and copper oxide and carbon dioxide is formed. So carbon dioxide gas turns the lime water chalky. So this will be the sign that carbonate ion is there. Stable carbonates such as sodium carbonate and potassium carbonate do not decompose when heated. So this is very important point to be noted. So now we are going to read the chloride ions. So chloride ions combine with silver ions to form the insoluble. So this is the general equation. So silver chloride is insoluble in dilute acids. So chloride ions also combine with lead ion to form the insoluble lead chloride. So here is the equation. Lead chloride does not dissolve in dilute acid. So if the thing that is formed is insoluble in the dilute acid, so that will be the sign that the chloride ion is there. So iodide ions combine with the silver ions to form the insoluble silver iodide. So if the ion combine with the silver ion and it forms insoluble silver iodide, so silver iodide is insoluble in dilute acid. So if the thing that is formed by the reaction of the ion with sample ion with the silver, so if it is insoluble in the dilute acid. So iodide ion also combined with the lead ion to form the insoluble lead iodide. So this will be the sign that iodide ion is there. Lead iodide is insoluble in cold water but dissolves in the hot water. So this will again be the sign that the iodide ion is there. So this is another test. Lead iodide does not dissolve in dilute acid. So you have to learn these points. So actually these are the points which will identify that iodide ion is there. The next that we are going to read is the sulfate ion. So sulfate combines with the barium ion to form the insoluble barium sulfate. Barium sulfate is insoluble in the dilute acid. So if our sample ion combined with the barium and the thing formed is insoluble in the dilute acid, so that will be the sign that sulfate ion is there. And sulfate ion also combined with the lead ion to form the insoluble lead sulfate. Next thing that we are going to read is the nitrate ion. Nitrate decomposes when heated. Two gases, nitrogen dioxide and oxygen, are given out. So this is the equation. Nitrogen dioxide is brown gas while oxygen is the colorless gas. Oxygen rekindles a glowing splinter. So this is the test. If this thing is happened, that shows that oxygen gas is there. So example is lead nitrate. So look now. When lead nitrate is heated, so lead oxide, nitrogen dioxide and oxygen gas is formed. So note two things. If a brown gas is formed, at the same time if the glowing splinter is there, so it means because the brown gas will not reglow the splinter, so it means oxygen gas is also there. So that will be the sign that the nitrate ion is there. So this is the identification of the nitrate ions. So nitrate can be reduced by the hydrogen to ammonia. The hydrogen is generated from the reaction between the aluminium and the sodium hydroxide. The ammonia liberated is detected. So this is again another test to identify that the nitrate ion is there. So ammonia liberated detected by using a piece of the damp red litmus or a drop of the concentrated hydrochloric acid. So this was the lecture, students. I hope so this will be much more easier for you now to understand, because this is a tough topic, I know. So you have to work a lot, you have to spend a lot of time on this topic to learn. So try to learn it. Because what to do, this is our syllabus and the questions from this topic will come into the paper. So read this lecture again, understand it, learn it and make your notes. Thank you so much.